All right. So we have angle SWT, that's this big angle, congruent to angle STW, this big angle. Then we have angle BTW, this is angle 1 right here, congruent to angle BWT, which is angle 2 right here. And we want to prove that SK, highlight it, we want to prove that SK is congruent to SF. This is not going to be a simple CPCTC. It's going to be beyond CPCTC. But regardless, the first starting point is going to be to find triangles to prove congruent. Does anybody see a pair of triangles we could potentially prove congruent? Oh, actually, I'm lying. This can be a straight CPCTC. There's two different ways to do this proof. There are two different ways to do this proof. I guess we'll go over both of them. I'm just looking. I noticed the other way. So you did it the quicker way? Okay. So if you did it the quicker way, which triangles did you choose to prove congruent? Sion.
SFW.
Yep.
And let me see, TSK or something.
You got it. SFW, this is the quicker way. And then we're looking at triangle SKT, these top overlapping triangles. All right, so let's start here. In these top overlapping triangles, right now we actually have nothing. We don't have any sides. We don't have any angles. This big red angle, they're too big. Angles 1 and angle 2 are not in those angles. But looking at the overlapping triangles, see angle 3 right here and angle 4 right here? Does anybody see a way we can get angle 3 and angle 4 to be congruent? Only Sion, really? Come on, somebody else can see a way to get 3 and 4 congruent. Sion and Simon, I need more of this. Don't deflate me. 3 people. Four or 5. There we go. We're getting better. All right, Michael, how? Subtraction, you got it. I'm going to say angle 3 is congruent to angle 4, subtraction. So that gives us an angle.
Yay.
Now I think almost everybody also, once you identify these triangles, could do angle S reflexive. Do we agree on that? We all see the angle S reflexive. So that's going to be another angle. So we'll say angle S congruent to angle S reflexive. But now we definitely need a side. We 100% need a side, and this was the tricky part in seeing this, in how to get this side. Kyle?
I just have a question. Why can't you say just from having angle 3 and angle 4 congruent that SF and SK are base angles?
All right, so your question is, when we were able to get 3 and 4 congruent, why can't we have SF and SK congruent? What would be your reason for having SF and SK congruent?
If base angles, then likes.
Gotcha. Okay, so when you use that base angles to sides theorem, it has to be one full triangle, like one whole triangle together, and they each need to be base angles in the same triangle. 3 and 4, they're not base angles. They don't even exist in the same triangle. Do you see? So like when we do base angles to sides, it has to be one full triangle, and they both have to be base angles in the same triangle. Does that make sense?
Yeah.
Got it.
Why wouldn't you be able to, like, since angle SWT is congruent to SW. Why wouldn't you be able to make SW congruent to ST?
That's exactly what we want to do.
Subtract it to make SK congruent to F.
Okay, so I'm going to, let's talk about your first part, which was absolutely correct. So we can say that SW is absolutely congruent to ST. Does everybody see why we're able to say SW is congruent to ST? No. Okay, do we see the big angle T congruent to the big angle W? And do you see the triangle STW, that main big triangle? Aren't those the base angles in that main big triangle? If the base angles are congruent, can we get the legs congruent? Yeah. That's why we're allowed to say that. So we're going to say ST is congruent to SW if base angles congruent, then sides congruent. Give me 1 second, Adrian. All right, so now the question was, well, why can't at this point we just use subtraction after we do base angles to sides? Well, we don't know how it's split. So, for example, if ST is 10, do we agree SW has to be 10? But we don't know that the bottom parts or the top parts are congruent. We don't know. So this could be 10, but this could be like 7 and 3, and this could be 6 and 4. So the only way we could use subtraction is if we got both bottom parts congruent. Then we can subtract.
Yeah, I did that. I just did subtraction.
Okay, so now, I'm not sure if you guys realize this, but we actually have enough to say the triangles are congruent. ST so we got that angle S reflexive. We have angle 3 congruent to angle 4, and we have the ST and SW. Isn't that angle side angle? Yeah, so step number 5 is triangle STK is congruent to triangle SWF, angle side angle. Now, are SF and SK, are they sides of these triangles? Absolutely. So this becomes a CPCTC. SK congruent to SF, CPCTC. I'm sorry?
I'm saying that this is definitely.
Oh my God.
All right, do we want to see the other way? We could have done this. No? Did anybody, well, I'll tell you if somebody did it. Did anybody prove the bottom triangle's congruent? Okay, so then we'll talk about that way, because the other way to do this, can I erase? 1 sec. What? It's a short lesson.
Okay.
We'll have time, don't worry. All right, can I erase now? Yeah? Okay.
What are we doing with SOHCAHTOA?
Oh, SOHCAHTOA is not until after trigonometry. That's not till after chapter 9. So it's like part of chapter 9, but like we first do chapter 9, then we do trigonometry. Okay, guys, so let's look at this. Now, if you were proving the bottom triangles first, so that was, surprisingly, even though the top triangles were easier, my initial instinct, I saw the bottom triangles first. And this is what I'm saying, we're getting to the point now where there are so many different ways, or we're going to get to the point where there's so many different ways to prove the same thing. All right, so back to our given, we have the big angle by T congruent to the big angle by W. We have angle 1 congruent to angle 2. So now we're using these overlapping triangles. So we have FTW and we have KTW. WT. We have the big angle by T congruent to the big angle by W. We have angle 2, which is right here, and angle 1, which is right here. So right now we have two angles. What else can we say we have? We have two angles. What else can we say, Mia? TW reflexive. So now we're going to get the triangles congruent. So triangle FTW congruent to triangle KWT, angle side angle. Now I'm going to CPCTC, TF, and WK, even though that's not really what we need. And then I know I'm going through this quickly because I want to make sure I could get through the lesson. Now I'm also going to say that ST and SW are congruent because base angles to sides. ST congruent to SW, base angles, then sides. And then I can use subtraction. So SF congruent to SK, subtraction. So that was my initial instinct to do it this way. How many people did it this way? Good. Or you tried. All right, I'm going to actually skip number 2. Remind me tomorrow on review day, or whenever I see you on review day, Monday, to do number 2. All right. So today we are going to learn another way to prove triangles congruent. We're going to learn another way to prove triangles congruent. And this method only works on right triangles. How do you know a triangle's a right triangle?
Two perpendicular lines, or if it's given.
Yeah, you have to have a right angle, exactly. So when you have a right angle, there's special names for the sides. Do you agree?
Yes.
The side across from the right angle, isn't it called the hypotenuse? And what is the other sides called? Who remembers? Julia? Legs. So for hypotenuse leg, which we shortcut as HL, you need the right triangles, and then you need the hypotenuses congruent, and you need one of the legs congruent. It doesn't matter which pair of legs are congruent.
It just has to be at least one leg.
Just at least one leg and the hypotenuse. Now, if you look at the if you look at the tick marks, what does this suggest? Angle, side, side. Are we allowed to use angle, side, side? No, remember, nothing inappropriate in class spelled out. So what are we doing? This is the exception to angle, side, side. We don't call it angle, side, side. We call it HL. It only works on right triangles. It only works on right triangles. So HL means hypotenuse leg. Only right triangles have hypotenuses. All right. Let's do a proof. Okay, so if it says BC is perpendicular to AC, what can I conclude? BC perpendicular to AC. There's a right angle where? Right at C. And then when it says BD is perpendicular to AD, what can we conclude? A, right angle, right by D. So in step number 2, I'm going to say angle C and angle D are right angles. Boys, no. And that's going to be depth of perpendicular. Now, I'm going to tell you, when using HL, when using hypotenuse leg, technically you do not need the right angles to be congruent. What does hypotenuse leg stand for? A hypotenuse and a leg. It's not angle side side, it's hypotenuse leg. So you need a right triangle because that identifies the hypotenuse and the leg, right? Because you can't have hypotenuse without a right triangle. But technically you don't need the right angles to be congruent. But in every other kind of proof, do you need right angles to be congruent? Yeah, so my advice to you is, even though it's not necessary, I still say you say it. So step number 3, we're going to say angle C congruent to angle D. Right angles are congruent. Then we have AC is congruent to AD. That's given.
Here's what I found.
All right, and what is it that we want to prove? Let's see. We want to prove that AB bisects angle CAD. For some reason, bisecting angles stumps a lot of people every time. When you bisect an angle, you don't get congruent segments. When you bisect an angle, what do you get? 2 congruent angles. Go to the middle letter. We're bisecting angle CAD. Middle letter's A. Look inside. Do you see 2 angles? Those are the 2 angles we need to show to be congruent. So my goal is to get 1 and 2 congruent. Can I do sides to angles and get 1 and 2 congruent? Legs to base angles. Can I do that? No. Why? They're not base angles in the same triangle. They're not base angles in the same triangle. So we can't do legs to base angles. So I'm going to prove these triangles congruent. Can we say AB reflexive? Yeah. So we're going to say AB congruent to AB reflexive. So now I'm going to look at my triangles, and I'm going to be like, oh no, ASS, angle side side, and my heart's going to start getting all agitated, right? And then I'll breathe easy again. Why? This is not angle side side. Because of the right angle, this becomes HL. So now I can go on and say triangle CAB is congruent to triangle DAB, HL. Can we ever have HL if there's not a right angle? No. Now what should I say? Finn? You got it. Now I'm going to say angle 1 is congruent to angle 2. For what reason, Vincent? CPCTC.
Wait.
Why wait? Okay, now that we have angle 1 congruent to angle 2, now can I say that AB bisects angle CAD? Yes, AB bisects angle CAD, def of bisect. All right, that's essentially the lesson. Let's do another one though. I'm going to skip number 2. Let's do number 3. Okay, so here we have that BE is congruent. Oh, no, not congruent. Sorry, I marked that wrong. BE is perpendicular to AD. Do we agree because it's perpendicular, I'm going to have 2 right angles over here, 1 and 2? And then it says AC is perpendicular to BD, so I have 2 right angles here, 3 and 4. So let's write this out. Angle 1, angle 2, angle 3, angle 4 are right angles. And that's just def of? No. Definition of a right angle is that it's 90 degrees. Good. Def of perpendicular. You got it. Now we have that AC is congruent to BE. So I hate marking these overlapping triangles when it's like this, but this is how we can mark it. All right, we need to prove that DE is congruent to DC. We need to prove that DE is congruent to DC. I will tell you, ADC and BDE, those triangles, those upside down overlapping ones will not work. It will end up being angle, it would end up being angle, side. It would end up being angle, side, which we can't use yet. So which triangles do we have to use? The bottom, top, however you want to look at it. These overlapping triangles up here. This one. And this one. What should I say about all these right angles? They're congruent. So angle 1 is congruent to angle 2, congruent to angle 3, congruent to angle 4. Right angles are congruent. All right, let's redraw these overlapping ones. AEB and BAC. I have angle 1 right here is a right angle, angle 4 right here is a right angle. We were told that EB is congruent to AC. So I already have an angle and a side. Does anybody see what else we can state? What else we can say? Mia. AB reflexive, you got it. Is this angle side side? Is this angle side side? No, what makes it not angle side side? Why, Sam? No, they're right here. It looks like ASS to me. ASS, right angle, side side. But why is this not angle side side? Oliver? Oscar, sorry.
Because the angle is not in between the sides.
No, that would be side angle side. But I'm saying this is not ASS. Because we're not allowed to use ASS. So what's the exception to ASS?
HL.
HL. How do I know this is HL and not ASS? Because of the right angle. Do we all see that main thing? Because if this wasn't a right angle, if this was just a loop, just for an angle marking congruent, then it would be ASS, and would we be allowed to use it? No, but this is not ASS. This is HL because of the right angle. That's the main concept here. So step number 5, I'm going to say triangle AEB is congruent to triangle BCA, not ASS, HL. All right, am I going to be able to say that ED is congruent to DC right now? No. I'm going to CPCTC 2 things, and you're allowed to CPCTC more than one thing. I'm going to CPCTC AE congruent to BC. Thank you.
Came to about 8 steps for me.
So that gets these two sides congruent. Does anybody know what else I'm going to CPCTC? Because I ultimately want to get this full side also congruent so I could use subtraction.
This is where you have to start looking ahead.
Yeah. Simon?
Angle EAB congruent CBA.
This whole angle and this whole angle.
Yes.
So let's say angle EAB congruent to angle CBA. CPCTC. I could have put that in the same step as number 6.
Yeah, you could have put that in the same step.
Yep, you can put it in the same step. I don't know why I did that, but it's okay.
It's okay.
So now, the reason I did this, does everybody see the upside down triangle ABD? Do we see that? ABD? Aren't those the main base angles in that big triangle? If the base angles are congruent, are the sides congruent?
Yes.
Yeah, the legs are congruent. So step number 8, I'm going to do base angles to sides. So I'm going to say DA is congruent to DB, base angles then sides, or legs. And then lastly, I can now say subtraction. So what is it that we want to prove? DE congruent to DC subtraction. That was a tough one, huh?
I was, once I looked ahead and I was like, oh, this is how it
This
works.
is how it works.
Yeah. I was
Nice.
able to do it.
Okay, so we are done.